So I went ahead and soldered the H-bridge. There we are. I did not film the soldering because I'm still trying to get a good setup for that. Trying to get the angle right, trying to make sure I don't make a ton of mistakes and have a 2-hour of video to edit. So I thought I would just go ahead and go over it for you. So the power source I've chosen is a barrel jack connector. I just got a little pack of these off of Amazon. Not too bad. Not really designed for this type of proto board. It doesn't have exactly the right pitch of pins on it. It's got 3 pins that go in there. One of them you see here on the side. Another one is right underneath. Both of those are connected inside, if you see at the bottom there. That connects to the outside of the barrel jack plug. And then on the back here, you have this pin, which connects to the center, and that's going to be your positive. Most barrel jacks that I've seen are what are called center positive. So I've taken 2 header pins, and I've just solder bridged over the negative, and I've jumpered the positive to basically break out the barrel jack, or I can use my bench power supply instead of the barrel jack. So 2 options. So to get the barrel jack on there, it fits almost right. I just had to use needle nose pliers to bend a couple of the little pins a little bit to get them to fit exactly in these holes. This kind of connector is more designed for if you are having PCBs made up and you can input the dimensions from the spec sheet of these and then have the holes drilled into your PCB. But it does work fine in a proto board if you just, force it a little bit. So I've got the 4 resistors, 220 ohms, and these pins are the 2 connectors for the signals. Doesn't matter which one, it's just one has to be 1 and one has to be 0. So one high, one low, the other high, the other low. Neither of them both high or both low at the same time. So this pin is solder bridged over to 2 resistors, and that pin is solder bridged over to the other 2. So 2 resistors are getting one signal, 2 resistors are getting the other. I have the 4 transistors here, the NPNs. They are the 2N2222A, or just generally 2N2222. You'll see that as the commonly available, commonly used transistor whenever you're not using the big power transistors, the ones rated for entire amps. This can take 800 milliamps of collector current, and it can take 625 milliwatts of power dissipation. That means when the transistor is closed off, then it can have a maximum voltage drop times the current going through it, P equals V times I. So voltage drop, highest voltage drop the transistor will ever have, times the current going through it, has to be less than or equal to 625 milliwatts. Now generally these transistors will be completely open or completely closed. So that's not going to matter. It's either going to have a voltage drop of near 0 or a current of near 0, which means in both cases a power dissipation of near 0. It's only during the switching that it won't, and the switching is very, very quick. So if it goes over the power rating by a little bit, it's not going to matter. It'll generate a little extra heat and it'll go right back into the air. So it'll be fine. That kind of power rating is more useful, or I should say more important, when you're doing something like an amplifier where it's going to be partially open and you have to make sure that how closed it is, how open it is, times the current through it at that time doesn't exceed the power. So I just used a mess of jumpers, it's very gross, I know, to connect the 4 bases to the signals, the other ends of the resistors. And I know anyone who's a professional is looking at this bird's nest of uninsulated wires and just screaming internally. Hopefully internally, otherwise you're waking your neighbors up. But it's good enough. I would not sell this. This is for me. I know how to be careful. This will not leave my house unless it's in the trash can. And then I've got the positive and negative of the power jumpered down to the collector, so the positive connected to the collectors of the top 2 transistors, the negative connected to the 2 emitters of the bottom 2 transistors, simple solder bridges there, and then finally the 2 load pins are right here between the transistors, there and there, that are connecting the 2, rather the emitter of the top 2, let's put it on top so I'm using the correct words, the emitter of the top 2, the collector of the bottom 2 connected together and then broken out into the load. And the reason I did it that way is I didn't plan ahead well enough, and I didn't want to run even more jumpers. I ran out of space. But in any case, it functions. There's not going to be that much heat dissipation. There's going to be almost no heat dissipation. So having the plugs right next to the transistors isn't going to hurt anything right now. So that's the H-bridge. I'm going to have another little board that's going to have the filters to turn the square wave into the sine wave because I want this separate. I want to be able to use an H-bridge on its own with nothing else. And there it is. So I can use this for testing motors, for testing oscillators, for testing anything that has a bidirectional current. And that's it. All you have to remember is that the signal is only connected by 220 ohm resistors. So in the case of my oscillator, that's perfectly fine because I have the PNP transistors as the open collector that can definitely take that current. And as we established, having a low load, a low impedance load, which 220 ohms is beneficial to the curve. The oscillator is affected by the load only a little bit. That's why we use the PNP transistors to break it out. So it's affecting the circuit as little as possible. So it won't affect the timing at all. It'll stay nice on schedule. But the charging and discharging curves, mainly the charging curve really, will be slowed and curved rather than the nice square wave if you have too much resistance through the PNP transistors. So this will make it nice and sharp. Other than that, there's not much more to say about this circuit. On to the next. Until then, be seeing you.